All right, that will be attached to this. And so I kind of want to make a long, just kind of angled chalk shape for either side. And then I will drill small holes, maybe just one small hole, and try to screw up and down through the back side of this into this. And this is 1.5 inches. And we're rubbing right onto the framing behind it, so I gotta be in there with like 1.25 inches. They're gonna be short and the attachment's going to be tenuous, and it is only in this little tiny aspect. This stick below and the one above is all sort of freewheeling, which I don't think is going to be robust enough. So I think that means that I should think about screwing a stick of wood down here and a ways there, up there, screwing that in and then screwing this to it. Ideally it would be inside the tube, and I would screw through it and sandwich the tube with the wood inside to this, which is a little more doable because a 3-inch screw may be used. If I used 1.5 inches inside, then there's a good 3/8 of an inch in thickness to the cardboard before we hit into the wood. So maybe that's the thing to do somehow. How to somehow do somehow. And, well, that'll be how I'll have to do it then. It'll have to be a good amount of length and screwed into from the outside through the cardboard. And then it's on board the tube, and do that on the bench. Then bring it over and make a little access hole and screw through the wood and into this. And then, I also made a hole here for the pipe to stick into. So I have to remember that we'll have to stop and start at this opening. In fact, everything below the opening won't matter because it's such a large opening that a 2x4 would be unable to fit. And any wider than that, you start pulling it in flat, which kind of sucks, but it also isn't the end of the world. No, I was going to say I could go wider and just jump across the gap to the wood with a longer screw, but you end up squeezing it out of, it's got a nice thick wall, but I still feel like I just want to be definitely pinching it. And you really ought to have a chalk in here because at the end of the day, it's able to roll on those connections, and it shouldn't be able to do that either. So I guess I'll have to install a 2x4 block down the back side of this and apply some chalks to either side of it, and maybe get that done and separately, and then bring them together and put it together. However, then it moves at the same, it moves positionally the same as the pendulous arms that need to clear enough to get the pipe out, and I need to make changes to them kind of overall in a bigger way. I'm going to make them longer. So what I'm saying is we're going to set this aside, even though we've got more of a plan now, and we've got that much to get done, but also primarily we're going to elongate the pendulum arms. We're going to take the cross piece, like I said before, we're going to scoot them down to this end, and we'll make another one for the other side, and just move it to where the taper begins at the front, and it'll do the same job. Won't hurt to have the two of them. We can hang the weight pack lower, and I believe it will still clear. In fact, it may not even have to come over even close to touching those before we're at the limit of how much tipping that we're going to do. So I'll probably remove the cross member and make the changes to the pendulum, etc., and prove out where it needs to be located, because if it needs to be scooted away a little further, it could be. I want to limit my back and forth on this maneuver. So I got two 10-foot 2x12s, and we'll chop those down into new pendulums. I'll pull the weight out of there, yada yada. See if we can't get that thing to maximize its geometry. There's no reason why we shouldn't have a longer lever arm. It'll just make our life easier, and now's the time to make that change, I think. So let's get her done. right, when in doubt, you got to draw it out. So I intended, if the ground to the top of this is 65 inches, it should be 65 and a quarter, but we're just going to try to be more careful than that, or just round it and make it easier. But when in doubt, you got to draw it out. I just rounded things a little bit here. It's 65 and a quarter actual, but I went 65 from the ground to the top of the framing, and then my intention was to use 60-inch long new pendulum, since that's 1/2 of a 10-foot stick, which is what I needed to move to do anything any better here. So if I were to maximize a 10-foot stick to get 2 pieces out of it, and I went to 60, then I quite obviously have 5 inches left to the ground, which is no problem. And then I needed to find out where I wanted to drill the hole for the weight from the end. So I know that the center line to the outside of the weights, which are 18 inches in diameter, is 9 inches. And so I wanted 2 inches of clearance between the weight and the floor itself, just in case toes or fingers or anything, for any reason, anything sticking up off the stage. 2 inches is a safety. So I went to 12 from the floor to the center line of the weight, which left 53 from the actual end of the piece. And then obviously you got 11 and a quarter in this, nominally, or not nominally, but theoretically, and then whatever's left of that from 60 is what it's going to need to have a second layer made. But I'll pull a tape measure on that, just because there's some things here that are, like I said, theoretical, but not necessarily accurate to the real life situation. For now, I know that making 2 60-inch long pieces and drilling the hole in this location and getting them screwed on there will allow me to limit the back and forth, just by working through the math here really quickly and double checking over there. Like I said, it's actually 65 and a quarter, so I get the 3/4 onto it, it'll be a 66, but I bought 5/8 plywood, and so it'll still be theoretically a tiny bit, 1/8 of an inch in theory, below the top step of those stair assemblies. But of course, that much variation happens out here. This is a 1/4 inch tolerance surface, in my experience. So we're not getting that precise, but just so that you are aware, you do have to do some thinking along these lines, and just throwing all of your precision out the window will really get you into trouble quickly. So you can see where I strike a balance here maybe. So now I can lop these pieces off and keep moving. All right, well, I'm trying not to use wide angle for every single shot. However, I end up with the action just outside of the framing, like what happened here. There were a couple different hole saws in play for the 2-inch pipe, and then there was the one for the 1.5-inch pipe. And for whatever reason, I made the notching happen over here, and then I went right over here for the hole for the weights, and I didn't drastically downsize to this 1.5-inch pipe sized hole. So I was a ways into this first layer of 2 before I realized this. And then I thought, well, I'll backfill the cut with construction adhesive and it'll be fine. But maybe I could get the actual hole cut through there. But in fact, it was so close to the size that I was cutting incorrectly that it was really reducing the wood that was left between the two and just making it a mess. So I called it quits. I filled everything here with construction adhesive, PL Max, and between it being a dry time of year and the wood being pretty dry, I hope that like tomorrow or the next day I can get that drill to go through that. So I'll make the other one, and actually I can install them. I'll drill the correct sized opening in this area on the other one on the bench, because that was an improvement over doing it in the air. However, I can do it in the air, and I've definitely done enough. I've got the pilot hole going all the way through. Somewhere there it is. So I'll have that, and so anyway, these could go up today. But that's all the farther I could go with it. So maybe there's no point. And then I've got, well, no, because I still have to get all the weight correct before I commit to the mast. The mast is going to be constantly in the way of switching the weight. Not necessarily though, I guess. Not necessarily, because the pipe could go out to the other side. So yeah, so if I get to that point where I could put those pendulums up and we're waiting to finish drilling through them and playing around with the weight can happen out the other side, then I can get back to getting the mast up here, because I think that's an important feature to have earlier on too. If this is features, these are features that are important so that we can get the experience of dealing with this tricky business for a longer amount of time. Same with this, but in kind of a different way. This is going to have the the threat of getting caught or being forgotten about being way up in the air. And so the sooner it's on there, the sooner we can watch out for the pitfalls where it might get caught on something or whatever else, any other number of things. So I really want to get some of the biggest main pieces of geometry roughed in so that we can make sure that the functionality is there in every way, and then we can continue to dial it up. So there's some things that I know that won't be a problem and they can wait for a little later, and some things like this that I want to get right to. The other thing I mentioned is, I guess I didn't talk about, I used some 2x4 blocks. I think I went with 4. And you got to be careful not to pull the middle down or you pull a flat into it, but just to be snug. And I screwed them into the original tube and into the tube that I got that I measured out with circumference to get as close as possible, and I got pretty close. On the inside surface, that's the more important one, because we're going to pull that inside surface into flush with the blocks all the way around. However, the sidewall of this purchased tube is about half as thick as the sidewall of this awning tube, because it's just a different application. This is far more robust. So I should have cut it exactly in half. I ended up actually putting the overall length, the same exact tube length as the tree tubes, just to be standardizing it. But then what was left wasn't quite the same, and I might have made them just 2 exact pieces. Anyway, I slid it and sleeved it around and pulled it in with some tape, and I screwed it again. But that brings our outside diameter really close. 2 layers gets us really close enough to tape and blend and lose the discrepancy there. I believe. So that's what happened with that. And I still may have to put a curve on the bottom of it. But for right now, let's put those pendulums up. I am annoyed that I miscut this, but it's not the end of the world. If I just wait, it'll be just fine. Like it was always going to be just fine. So yes, I'll do what I can, and then I'll have to do this another day. So I has set this up and I ripped a 2x4 directly in half at 45 degrees and made myself two just sort of chalk shapes here. They'll end up probably being cut flush with the top of the deck of the piece, which will actually be up here, so I'll wait for that. And then that'll support it all the way down this leg. Now I reused the 2x12 here because it was going to be wide enough, and it's going to leave me, like I slid these over till they stopped on the tube when it was here. So I knew that there's a little bit more meat showing, and it's coplanar with this, and that's going to end up allowing me to attach something to the face of this, because when we're looking at this inside the ship, where the stage is the deck of the ship, we're going to need to cover that up. And so it's going to need to have some kind of a surface, and I'm not going to frame it all down, and I'm not just going to hang glue on there. We're going to need to catch the edges of some glue on if we use it. So anyway, worked out nicely to reuse this piece from the other pendulums. Is it a little bit short? Yeah. I don't know that I need the chalks to go all the way to the floor. So for now, they're short enough to not scrub when I tip this thing back and forth. And I'll end up probably putting a 2x4 behind there all the way across, just because it's lightweight enough, and anchor into it there, and that'll hold the bottom edge of whatever surface is on here and give me enough meat to also attach a skirt from there down, so that it visually practically gets to the floor, but it can be squunched up when the ship is moving. Same with the bow at the front. It's going to have some kind of a transition to fabric or something, with like a bent PVC or something like that to hold it down like half an inch off the floor. But when we are tipping the ship around, it'll kind of crumple against the floor. Just maintain the silhouette. We can't be in the air the whole time or it won't look right. We can't build close to the floor because it'll be an interruption when we try to tip. So I've got to make sure that I accommodate that all the way around. So all things considered, I could now, I could put the tube up here, make a clearance hole, and screw through it into this, but I'd rather, like I said, have a block inside. So that's what I went ahead and did here. While I was there, I marked off with a pencil line where the top of the deck is, so I don't need to worry about that. And then that was about 64 inches, so I went down and grabbed a 2x4 and cut it about that length. And then I made sure that it was centered in the opening here, and I moved it away from the bottom by a couple of inches so it won't be hitting in there. But it did end up in the way of one of the blocks inside, so I had to pop that off. It's doing the job of that block right here right now, and I screwed in here again right on either side of this hole. It's just a different colored screw there, and then another one here, because I intend for this to be a block and this to be a block, but I had no way of controlling this one in here and trying to hold it and everything else I didn't want to deal with. So I just put it in as one. Now I'm going to carefully re-drill this hole, which it'll also float and register on the cap. Anyway, I get that far. Then when I come through, I will be using these heavy screws. We'll be coming through it to clearance, screwing into this and running it until it stops, and thereby I'll have an inch or so in the meat on here. And I think just one at the top, one at the bottom, toward the bottom here, maybe one in the middle. Good enough. That means that it's attached to this wood, and even though it's two separate blocks, the failure is basically in these small sticks, but you'd really have to be moving and crank into something to break it off. I think it'll be robust enough to maintain the geometry so it looks nice and plumb and 90 degrees to the deck, and it'll take kind of a beating, and the kids can even push on it incidentally as a place to push on the set itself, and it won't really ruin anything. And that's where making these transitions from ultra lightweight in this geometry to have a 1 foot diameter, 14 foot long now cylinder, to do it in sonotube would be even lighter. This isn't too bad, even though the wall is thicker, but there are actually benefits to that. It's a little heavier, but then attaching to something that's far heavier, making the transition between ultralight and heavy and solid, you have to be careful about the way that you do it, or the lightweight thing just breaks and rips off of the heavier thing. So those transitions pop up all over the place in this type of construction. So I'm just taking a minute here to talk about how much I'm thinking about making sure that we don't have a failure that I have to come back and operate on at some other point. Nothing worse than going backwards on the project before you can go forward again. It's already happened in the pipe. It's happened in the pendulum arms on this. It'll probably happen a few more times on this, and that's just the way that brand new, custom engineered, trial and error, test and tune, like designing to get the most out of the least. And it just goes like that. You got to be comfortable with it a little bit. So I try not to do too much of it. I try to plan as much as it humanly possible. I do want to show when I have to go backward to go forward, and I had to fill the glue or fill the inappropriately drilled opening with glue before I went too far there, and the way that I had to make these changes. So anyway, it's just an ongoing kind of process like that. But at this point, I cannot apply this even after I drill it. I can't put it up because I really don't want to take it down, put it up, take it down, put it down. And this is just hand tight right now. Swear to God. There. So I'd rather really crank it on before I bury it behind something where I can't get to it. I'm not going to drill nearly as big of a hole in the front of the tube to address it, or even be able to put my hand through. So it's got to be on there real good. In fact, it's got to just start first. There you go. So, and I'm going to need somebody on the other side probably, although maybe not. It might be held enough with all those layers and the weight pressing. But I got to get a wrench, which I haven't got, and tighten it on. And then I can put the tube up and probably, just try to leave it up there. So I'm at an impasse today. Then I want to put the 6x6s in here and here. And I could figure this out. But since I got to get out of here for 3 o'clock, I got to get out of here in the next 5 to 10 to get home by 3 today. I want to scoot them over, and we know that this is 22, but we don't know what this angle is. If this is 90, I don't have that on here anywhere, geometrically speaking, where I can gather what the actual angle should be made at. I'd rather just check it in CAD. I could move over 5.5 over here and put a square on and project over to this component. Because this is 22, so I could measure from that point over 5.5, which is this width, and project with a square over here and figure out where the point was that it would intersect, and then I could literally measure from that point to this point and measure and just put those two measurements on and connect them. However, I don't have a square that's long enough to reach. It'll go to about there. I've just got the framer square, the 2-footer. I don't have a T-square or anything larger here. So rather than playing all around, obviously wood has got a straight enough edge on it and whatever else I could do it. But like I said, I got to get going. So we're going to hold off. We're going to get the number, the angle that we need. We're going to get a couple of wrenches so we can tighten the caps on. We're going to get something else that I can't recall at this moment. Yeah, there was something else too. So anyway, what else was I going to mention? Oh, I'm pleased to see that the wheel, the caster's not going to scrub the back. This plane is a good 1/2 inch away from that. I'm pleased that I'll be able to support a surface here with a very minimal thickness. And, every degree that I could have moved the mast out, and I even played around with setting it in the middle of the stage loose on a rolling base like that. But then it just became, in my mind, not only could it would look good out here from this angle, but turned the other way, it needs to move with the deck. So it kind of needed to attach to this for that at least. And the easiest thing to do is to just put it on and leave it on. I could have probably made it so that it would attach for this. In fact, I could have done everything that I'm doing and leave this one attached and made a second one to roll out here to really sell it. So if this ship was something that we were on the deck of it in Act 2, and there were more musical numbers on it, and it would be better to have it more dimensional, I might have made another mast, and I wouldn't have brought it out when the ship is pointed at the audience. But when we turn it around, I would have brought it out and parked it here in the middle, and maybe brought in another sail over top. If this whole show had a big component that happened on a tall sailing ship, then we could do that. But that's not the situation right now. So we're making concessions and sacrifices. We're trying to think clearly. We're trying not to do too much rework. And so we're going to regroup at the shop, gain some tools and some information, and then we'll come back and hit this a little bit harder. Well, I take that back. I was going to just tack it up to get a little satisfaction, and I will be doing it through these openings, but this is all the longer that the screw can be to go through that block, which is close to this inside. Since the face of it is there, it's actually back here. So anyway, the problem is that I can't reach through there and run this down tightly. I can only barely get started with the extension that I've got. And I haven't got any more of those. So now I'm stuck. So I got to make a list of all those things that I need to keep moving. And then when I come back tomorrow, I can pin that together and start there. So I'm starting off today just modeling a idea for this basking rock set piece that has been in my head for a few weeks now. I've just been, honing in, and it's also had me thinking about where an idea like this comes from. Hopefully it seems really, elegant, and that's, the point of it. Fewest amount of components, simplest type of construction, best looking end result, and, really, as lightweight as necessary, but also heavy where it has to be. And, the fewest number of moving parts is all design criteria, almost always, but, specifically in this project. So to start with, I made a scale piece of 4x8 sheet good material, which I expect to use 3/4 inch plywood, which was enough to make this profile and this profile. So these two, like this jelly bean that's like folded in half, is a total of 12 by whatever this is, and then back up here is 24. So it's a full 4x8. So then you can kind of get those two pieces out of it, and then I'll need some other 3/4 inch plywood, but not a full sheet, to create this bottom profile that tips up, and a couple bulkheads. So I show the bulkhead here. These are right on the center line of the 4-foot dimension, but it doesn't look like it's the center of this, which is just no big deal. I think that I'm going to end up with a set of them, one under the center line of this wheel and the other one under the center line of that wheel, and that thereby we have the fewest number where it's as structurally supportive as possible in the event that it makes sense to have somebody on it and wheel them out, or even just in like clambering and climbing around on this. Instead of closing this gap like that, it'll end up being vertically loaded structurally all the way down to a contact point. And I'm trying to keep it so, just like this. If you go too high with the caster, and it can flop over on its side in this stopped position, then tipping this back up and getting started can be kind of annoying. So the geometry is actually designed to keep the caster from really pivoting. You run all around wherever you go. When you set it down, it's actually touching, or just, it wouldn't hurt if it's off the floor, but I don't want it making this wishy-washy anywhere. The point is to fully relieve the wheel, but to keep it kind of in that position, because I want this full surface to engage the floor whenever you set it down. Then you have a nice big, that was our problem, is if it's moving on wheels and wherever you go and you stop, then when you try to climb on it or whatever, it's clattering around and moving. So when you sit this down, it sits flat and it sits tightly to the floor. And I think I'm also going to end up with a couple of brick weights down in here, installed from the edges maybe, and then something to hold them down in there. So it'll be a little work to pick it up and leave with it, but it really wants to sit down, and you can really climb out and go up on it in an impressive amount is my goal. But I think finally, the one thing that we'll have to, we'll have to remember that this is too much flat surface. I actually want to be additive between these two bulkheads with like loops of ram board, and ultimately build something more like this in profile between the two of them, that kind of comes around like that. And then from here down, I intend to have like a canvas skirt of some kind, and it'll actually be there'll be a tube in this position, probably slid in there and stopped, but then we can just bend something out and make like a loop of steel wire or something like that, relatively heavy rod basically, or plastic PVC, and put that in a hem in the bottom of the canvas so it sits down tightly to the floor. But when we pick this thing up, the loop just stays on the floor, and the canvas kind of accordions up a little bit, enough to make it so we can roll. The loop kind of keeps it under the same kind of profile as the rest of the stone, and it keeps it from engaging with and getting tangled with the wheel. But it should just automatically set itself that way, basically. It can just like squeeze up, and wherever you go with this thing, you set it down. Everything's all painted together. It's bulky, and I'd like to probably go up and onto the top of it a ways, so that you end up with just a more of a dished, shallow center side. And the last thing I want to do with this piece is, not only I think it's going to be staged right, so it's coming at you like this when she comes up on it as a basking rock, but I'd like for there to be a supplemental like rock outcropping on this side. And on the other side, so that on the other side it actually visually obscures how pointy this is and maybe plays out in front of it a little bit. And then actually full on like this, the combination of all three of them makes a rock that you don't really associate with the set piece. It's just a couple different views of the set piece. So we've got somewhere for scuttle to land. We've got, a background element to make sure we know we're above water but near the water. In this stone from a few different angles, and it's just really easy to use, hopefully. And I'm on my way here. I think we're just going to make a few more changes. The idea was to be able to pop this apart, scan the shapes, and then enlarge them and literally translate them out. But I think, like I said, if I just go around from 4 foot to almost the whole 8 foot end, and then back to 4 foot and around to the other 8 foot end to make those 2 pieces, and I figure out what my angles are here, it looks like the top one is slightly smaller than the bottom one. I'll probably make it 50-50, so whatever my middle finger angle and the index finger angle will be the same angle. And I can just make a few pieces like that are just a few inches long, at whatever location the loop falls, and leave them long until installed. And then once they're installed, I could scribe around on them, just sawzall these all in place. I mean, you could exclusively design this whole thing, but I don't think that's worth it. Once again, I did it in scale so I can get some quick checks in, like the angle measurement and everything else, but I mean, the casters aren't completely perfectly at this scale, so I'm going to have to play around with the size of this thing. And when you start thinking about it, it would be nice if I basically wanted the shape of the three-dimensional rock, not only to grow forward and up, but also from under and out and around, kind of all the way, to make it the most organic kind of possible shape, and impossibly like undercut too, I think is visually more spectacular than spreading out from here down is very excusable and really probably wouldn't ruffle anybody's jimmies. But I just like to undercut a piece like this because I think it continues to play with your perception as far as, how much production value there is. It would look stable and be stable the other way. It's going to be just as stable this way, but it's going to look like, hey, if that was a set piece, it would be kind of tough it looks unstable. I like that aspect. So that's how my design kind of, heads in that direction. I think a couple bulkheads is an improvement over this. And then we're just going to ad hoc, once we have them in there, just get those strips of material to bulk out the shape of the rock. And then when we're all done, just some crinkled up paper glued to everything. And in fact, no, maybe I'll just try to get a really wrinkled up canvas, like a drop cloth, and use it from here up, and then just start applying it. Yeah, I think that's the smartest thing. Using the canvas will be what I skin the whole thing with fabric and then paint the fabric, which will give it more body here too, so it just kind of crinkles and uncrinkles in the same way. Hopefully the crinkling looks like stone as much as it leaves us flexible. But I think, and then we've got some other fine tuning at the end for texture and coloration stuff, get some algae on it, and it's going to be cool. I wanted to do the fog geyser under it, so you get the splash of water out in front of her at the height of the song. There's a chance we could do another stone for that sequence and put a fog geyser right in it and just put it here so that it blows up right in front of her. That could be cool. Let's not get ahead of ourselves. First, I got to start making this piece in real life, and that's after I make sure I'm really satisfied with this model. So the wire represents the whatever I'll use to hold down the canvas edge of the skin to this thing, and I've got a tube I rolled up some paper and just put it across at the back of this that does the job. It'll allow this to tip up, and it would pull the fabric back down from this bulkhead if it was all baggy in there. And, it would work all right. But I started to see that I'm going to have this, like, if I'm using cardboard, probably wider pieces, I may even overlap them and screw them together. So it's actually a solid kind of segmented cardboard kind of infrastructure. But if I've always got to go back to this, it's always curving down to there, and then whatever that fabric's going to do is going to immediately have a different kind of shape. And I started thinking, like, if there's a straight line through at the back, there's also this straight line through right in front of the wheels themselves. So what if the loop just pivoted about that point and it just flipped up a little bit there? That would allow me to make choices with the way that the canvas lays to this point. And really it's just that last little bit, because look at how little this has to come up in general. Where this is flat on top, it's just a tiny little angle change. So I think I'm going to go that route. And so I started over here with this idea where I could use the concrete, or the cardboard. I keep saying concrete. I could choose to go in and out. I didn't quite have the length that I wanted there, but I can create more choices in the shape of the stone, and I like that. So I'm going to rearrange this pivot and move this loop forward to there and do a little bit more work here and see if it isn't more along the lines of what I want to see. Okay, I'm fairly happy with this. It picks up and rolls as I planned. I do like just the little tiny loop down here, and I think that the loft between it and the underside of this and around is going to be interesting. I've also got these sides undercutting, which I think is a better look than bubbling. It's going to take the fabric to a point. So what we basically need here is like the toe of a sock, if you could have it, ideally in fabric, and it would come down, and basically the plane of the surface would be where it was cut off. And so to that end, I think I'm going to start with trying to fold. I'm going to spray the whole thing with spray glue, and I'm going to try to fold fabric, this plane folded over to this plane, and just sort of gather it and try to get the wrinkles to play out, because you're going to have to bring it together, but I don't want to make it too fabric-like, but basically bring it in all the way around, and then it'll be long past this plane, and then I can cut it off past there and see what we get. I'm going to want it a little longer here to try and make a little glued over hem to trap this little bar. And I don't expect this to work perfectly because the thickness of the fabric and the weight of the bar, nothing's to scale in that way. It's just a physical scale here. But I think if I'm going to use a black t-shirt rag, it'll start black, and then I could even do a little bit of dry brush on it once I've got the fabric styled along lines that I want to style it. And it'll also allow me to carefully use a razor blade and cut like a window out to expose the construction style. Or, cut half of it off and leave one side exposed and one side. For, you never know, like a model like this is worth doing to make sure I get my proportions right and I don't waste a costly sheet of plywood or do any back work. With the decisions that I made here and was able to check, I didn't have to really waste any material. But then, later it will be a cool model to have around for discussion purposes. So just trying to think ahead. Let's try to put a skin on it and see how that looks. So now I've got a natural stop at each of those two cross members that are new in the bottom at the pendulum arm, but I won't need to even get there. In fact, I think the weights are bigger around than that, so we'll probably stop short of there, but I still think we may not even swing that far in the performance. We may continue to reduce the movement down to where the positive stops that will be out here will end up going. I think it's a best practice not to have a pinch point down there where people are operating it anyway. But, worst case scenario, it's a redundant and built-in sort of safety insurance on that situation. And the mast is moving along with, and it's on there really good, which is what I want, and I don't want anything flimsy. A little bit of tape over those, no big deal. So everything's off the stage for tomorrow. I'm going to take off, and really I need to cover my son so my wife can get some free time before she goes back to teaching Monday, when I'll be back here Monday, and they're going to do some lights and some other work on the stage before I get here. So I cleaned the place up a little bit. I got the 3 of the 4 things done that I wanted. I got the pipe wrench on the caps, and I tightened them up. I didn't need to hold it anywhere else. I just used one big wrench. The openings through the 6x6 is holding it fast enough, tight enough. So I tightened that. I put this up with the extensions that I didn't have last time. I got these pieces in because I used CAD Quick to figure out the angle, which was 14 degrees. Removed for a total of 76 left on the stick itself. The one worked in the one position. The one had to be lopped off of an 8-foot piece, which is the rest of it there. I did have this piece already, which is like 5 feet, but I think it's going to be practically perfect for the helm. I need something to stick up from this deck in the middle there, and to come and go with this the way that the mast does, and have a hole through it. And then I think I'm probably just going to draw a ship's wheel in CAD and have it CNC cut down in the tech lab out of like 3/4 inch plywood. So I got to play around and make sure I know what size and stuff I want, this and that. But we'll end up putting that piece up through from below, and it'll just make a quick and easy thing to drill a hole through and throw the ship's wheel on. It may need to be bulked up a little bit more. I got some gold foil coming with like a pebbly texture. You can also get gold aluminum foil. And so I'm going to try and do some what looks like brass decorations. The ship, the Prince is supposed to be ballin'. It's not like a pirate ship or anything. It's going to be kind of dressy. So I'm going to have a few details, and in lieu of details, some bright brass with some green, some darker bronze, and some green patina in areas that aren't as well worn, but leaving it the bright gold at the top and some of those other things, I think is going to make this really jump out at you. I am still torn on whether this should be the bow and someone should stand behind the ship's wheel when we're facing the audience, and then it should be the stern when the audience is looking this way, and the person could turn around and stand behind the wheel, just so that who's ever at the wheel makes it clear which direction the ship's going. The unfortunate part of being at the wheel in this orientation, when we're looking at this way, is that one way or the other, your face is behind the mast, and so maybe we wouldn't block somebody behind the wheel in that case. But it would still be there. And to see the ship like that, looking at the wheel like that, it's implied that we're looking at the back of the ship. So if I end up with a bow feature that comes up to a point so that we're looking at it from the front and it looks correct, then it really won't look right. This is me being a stickler kind of, but you never want to underestimate the little subtle things that will help people visually understand where they are and making it that much of an improvement with the set. So what am I getting at? There's a chance that I would finish the exterior here as the stern, as the back of the ship, and have us just looking, as the audience perspective, at the action happening at the back of the ship. And, I know it may be a little counterintuitive, but you may look from that angle just as you would the other. I'm not sure what I want to do yet, so I'm not going to put the helm post up. We do need the wheel, so I'll get that ball rolling. But I want to make mention of the fact that I've been thinking about what to do about that, because the ship's wheel is on the back of the ship. It's not at the front. So it's extremely foreshortened bow, but it really is weird to be standing there looking over the bow with a ship's wheel. It's just, for the mariners, out there, kind of a problem. So there's that to be thinking about. This, I think I'm going to play the old two sides trick to the audience of Louie's oven with the fog geyser at the top of it underneath this stock pot blowing up during the song where he's chopping and prepping at the rolling butcher top. And then the other two sides, when you turn around this and this, really organic and coral, and the same the fog geyser in there, and it just nice smooth rolling. This is a nice cart to us, but covered completely and wrinkled paper and stuff with some angry kind of evil features coming up for an alchemy kind of a station for not Elvira, Ursula. So she'll have to stand and work over it, and obviously the pot won't be there, but the fog geyser can underlight her LED color of choice, and she can do her magic there. And it's the same special effect technical build out to the cart. It's a nice smooth rolling unit, like I said, and the two sides that are going to be the oven, I think I'm going to utilize as much of the gold bar features. I'll probably have to put a surface across the top so that the pot's more up here, which is fine. Geyser will sit there at the top, and it's just one of those things where I want to take advantage of the perfect geometrical bars and make them look brass and shiny and everything like that. I have to have some kind of a skirt to obscure the wheels and stuff. A burner, it'll have the orange red light going underneath there and the stock pot on it and what looks like a burner. But the burner will probably have to come off as well as the pot. And then when you turn it around, that will be something that looks correct. It'll just be a matter of getting that to look correct from both sides without having the back of one of the other features kind of being seen. The nice thing is that from the audience, you look at you look from a low angle, you're looking up at things. So looking down into the top of anything like that is an impossibility. You can see the top of the butcher top there, and I get to here, and at that kind of counter height, that's the eye line of the people in the back row. And so maybe standing in the back of the house, you could get a tiny little sliver of what's going on. But just want to be aware of what you do and don't have to show and hide. So there's that going on. The decking for this is also a part of coming up with the helm and doing all of that. But I think I'll put it in there. This is 16 feet even. So 8 feet will go from here to the center and from there over. And I'll put the full 4x8 sheets on here because this is only 36 to the outside. So they'll hang off and they'll hang off to here. And then I think I will bend an arc and whatever profile, whether it's a transom because we're doing the stern or it's the bow, whatever profile I'm going to put down to the floor, I'm going to put on the edge of the plywood deck so I can put blocks along it, start there, and start, controlling that shape. Without that, I'm just out in space here, and it doesn't matter that there's negativity in there. Again, the audience would never see that, but I think there's no point in chopping that plywood to fit this shape and then trying to come out here and get a hold of something else. So we'll take the opportunity in having that material out here to use it to pick the shape that we're going to loft down and underneath to make that boat hull shape. So, that's something that's hanging out as well, and that'll make it 4 feet. I'll probably go to the limit of what I've got there, 4 feet to here, and then we've got another 1 foot to here, so we've got a total 5 feet of width that we're going to try not to break out of, but we'll see how that goes. So for now, in good shape, and back again Monday to hammer on some of that stuff. So I think we already said the new and improved, reliable, heavy-duty short caster. Ooh, with sealed bearing. The whole layout isn't the same or remotely similar to the whole layout in these steel plates from the old wheel. So I've got to take all the stuff and the walls off of that disc truck and stand it up edgewise, and then get on each of those nuts and bolts with a wrench and a socket. Now that the pan's been glued in, since I figured we'd just leave it alone for a good long time and take it all apart, get the steel plates out of there, and then go back to the fabricator with the holy geometry here. I'll work out what the new bolt pattern location is, but they'll either have to burn a socket to set this back into a piece of metal on the plasma jet, and then burn in the new bolt pattern anywhere based on that opening's center as a jig. but I think it's overall, yeah, it's bigger overall, so you never accidentally get real close to those, but it'd be better if it went at 90 degrees, so you want a little tick mark in the jig so you know to put it at roughly what clocked angle, or transfer punch and like iron horse it, or iron worker punch it. I don't know what they're going to do exactly, but it's a real big pain in my ass now because these just can't take the weight. And now upon closer inspection, of course they can't. I mean, look at that versus the robust nature of this, clearly. For things that will have people's weight or significant weight overall. All the tree trunks and all of that, they could have been something like this. Maybe larger is a better idea. We use the short because I want to keep the thickness of that truck in particular short overall. I don't mind having the taller cake pans and using a larger wheel in these trees. It's just an overly heavy duty Rose brand wheel. It won't hurt our professionalism and our level of safety around here to keep them in there and just keep adding to our collection. But they don't weigh anything, and it's more a set piece like that that you want those for. So, you know, no harm in having a cheaper caster, just in circumstances where you can't accidentally overload it, is a better bet. And I still am a fan of standardizing. If we go with just these and just the other Rose brand casters around here, after a while we'll have a real easy time of you know, service and maintenance, repair and improvements. All right, so now with the two sheets on here, I know that if I come from this front point and I bend something on top where this will support us against gravity, I can work underneath here, but then I need more hands. So again, from the front center bending, then I drilled up this outside corner. You can see the hole here. So that's where that is. I just got to go by there, and then I'm going to keep curving to where I get to here somewhere, probably best right here. Here, you know, it's make 61.5 dozen. But ideally, you're talking about this point right there. So I go to this point, just past the hole and to the front, and try to get a point to happen if I'm going for the bow of the ship. So this is kind of when, you know, it becomes time to decide, am I doing the bow or are we gonna have the stern? I think that making the stern is a totally functional thing to do, but it puts the audience in a position where they're looking over our shoulder at this action that takes place. And I just think, for the purposes of this production, that we need the nose of the ship, the bow of the ship coming at you. There's just, I think it's asking too much for us to make this much of a set piece and have it be the back end of a tall sailing ship and not the bow, I guess. I don't know. I'm just kind of torn on it. And it all came from which side of the steering wheel should you stand on, and where the steering wheel technically is. It's at the back, or at least midship. It's never in the front half, really. So, in this type of a ship. So, I'm down to making a decision here. Because technically, I wouldn't want to point if it was the stern. I'd want it to be flat across, which would mean I'd probably have a bit of a curve there that went around the corner and continued into the side of the stairs. But then a bowing face. So, worst case scenario, if it really needs to become the stern, we can cut the bow shape back. So we'll cut a bow shape in. We'll keep moving as though it's the bow, and I guess reserve the right to change our mind at the last minute if so. Okay, so I screwed through that down there. I drilled a hole first to hold it, and then I put this larger construction screw right in that hole that's on that outside corner, but I went by on the outside. And then I took the face of this pipe. I mean, ideally you'd have a strip that was a square, but this won't hurt anything. So I took the face of it, past the center line to flush, and then I've traced the outside. So how do I replicate that exactly on the other side? Actually, I'm going to cut this carefully. I'll take the negative and I'll flip it over there, and I'll trace the negative piece over there, and then I'll cut that. And then I should have much closer to a mirror image, because as you can see, if I pivot here, I move the line a little bit. So before I get too many, I'm going to just average that and do a nice smooth jigsaw pass. And then, like I say, I'll use the negative and trace it over there. And if we come back and we want this to be the stern of the ship, we can start at some point here on the curve at the same distance from there and just cut straight across to it and just make a different flat face to look like kind of a transom if we end up changing our mind. But for now, we're going to put this go to the limit of what we had for plywood, so that we leverage this, cheat or whatever. We leverage the utility here to the maximum, and then if we want to dial it back from there, we can, just to be smart. All right, this morning I'm working on a ship's wheel, and so I brought, just finish this. I brought a model of a 6-foot tall person into the overall model, and I just wanted to get a sense of, the way that it would look, whether a person would be looking over or through. Oh, this is a better way to sketches on the other side of him, but it's on this back plane for whatever reason. So, what's my overall diameter? I can get to a 48-inch overall diameter before I'm off of half a sheet of plywood, or off of the smallest width. Obviously, want to work inside of that if I'm going for all one piece. If I wanted to be real crazy, I could go a little bit bigger here, because we're actually dealing with the straight line between this highest point and that highest point. As well as the same thing on the other side. That's actually, if I were to clock the layout, I could get a little bigger diameter, because I've got the ability to skip flat side by a touch. Pedantry. So, more realistically, we'll just call it a master 48 inches, so that's the handles. I looked it up. It's commonly 6 and 8 spindles and handles, sometimes 10. I had 12 in here, and I thought it was looking better, but I don't want to get away from what would be acceptable from a fundamental standpoint. I just find that annoying. If there's somebody in the crowd that knows, I would rather that they pull me aside to say, hey, I noticed 10 handles on that thing, or whatever. More realistic. I don't know. Unimportant to some. I think a lot of times what sells my work in building fake stuff is attention to the details that specifically sell the realism. And there are, there's doing everything that you see, and then there's just the top level stuff, the initial checks that most people's brain run before they just accept. And especially when you're trying to cut cost and time, that's what you have to stay involved with. So we're having that crisis, I am, about whether or not the wheels on the front or the back of this ship and whatever. When I've squished a whole ship down, its overall length down to a few feet, so it can get out of control, and I'm trying to maintain a healthy balance. That being said, I digress. I think that at 36 inches to the center line with a 48-inch wheel layout, which has the inner circle at, now we can drill into the sketch here, and we'll go back into the sketch. Is it on here? Oh, 28-inch inner circle, and then, or no, that's the inner opening. Then there's a dimension here somewhere, right there, 36. So it's 48 at the outside of the handles, 36 at the first outside edge of a full circle, 28 on the inside, and then we've got another spindle here. So it's just about to or polar array that. I don't know why it says circular. God, the dumbification. The geometry that we want is this spindle, and I pull a dash window or a unbroken window just to highlight those lines. The axis is the center line, and it's got 6 instances in here, but I think, like I said, if we went to 8, notice how they also don't line up. We have to go to 10, and then there's one for each, as long as the original is drawn on the same center line as the original handle. So then we can say okay, and it'll create those for us. I can make these are dashed lines or construction lines, so I can actually, I'd rather draw arc now between this complete line to the next. Move in here. This is to create a tool path. So I've got an unbroken line from there to there, but not through the handle. Once again, there's a circle there to lay everything out, and then I think I actually have to sneak in here because I just saw something. Discrepancy? Perhaps not. I'm just going to cut this out of plywood with the CNC. Oh, shizer. And I'm going to ask that it be cut out of plywood on the CNC. And I'm going to go back about my business. Could I draw one of these and polar array it as well? Yeah, but then if I run into a problem like that, I don't know why that is. Here to there, snap to there. Is it snapping to something else? Oh, great. So I can hunt that problem down and try to create a final sketch set of lines and send that to be cut from 3/4 inch plywood, I think, and we'll just try to keep it around. The neck of all the smallest areas is 1 inch wide, so it's a bit wider than it is thick. The handle itself is 1.5 inches, so it's a decent amount. And I expect the cutter is circular, absolutely is, and so all the inside corners will be rounded with a nice big radius, which should help it stay strong. And if you wanted to do your very best with this and keep something around forever without the handles getting broken off that easily, you'd go for a 7 or a 9 layer plywood, hardwood plywood or whatever. A 4, 5, 6 layer builder grade plywood is going to have an easier time of just snapping. There very well may be a knot hole right in one of these weaker areas, and then it just pops apart there anyway. So there's a chance that I'll try to find some of the nicer quality plywood that we ordered in the past by accident, kicking around in the basement rather than going out to buy. In fact, I could even squeeze this a little bit. So that's the last thing I'll add, is that I will try to find a scrap, and if it's a little smaller than 48, we'll squeeze the overall design a bit. But I know that a 36-inch center hole is a good location, so however much taller than that, basically 40 inches from the deck, I could put that 6x6 through and start thinking about how I want to do a pivot. The pipe nipple with a cap on both ends is a nice solution in these cases. It's, you could put a big heavy screw, but then it's going to wobble around or whatever else. So it just ends up becoming easier to even a 1/2 inch pipe nipple would be fine in this application. So we'll see what we end up doing here. Okay, I had to do a little bit of trickery to get that to array in complete lines and some construction lines without problem, so that when I send it to a CNC to cut, I've got what I need. So I was able to actually extrude the shape, and now I can just right click, export the face as DXF, put it wherever I want, and move on from there. And then as far as the overall drawing, I was able to just quickly, it shows him in there now. And I'm also able to show triangle that I was doing yesterday, where I wanted to be significantly above the diameter of the weight, which I didn't end up including in the model so far. But I know that was 33 inches from the bottom surface of the of this deck, right? And on the center line, under the pivot of the post, from there out to the back side of the stringer that's coming at us is 58.5. And I measured that in real life. And I just wanted to know thereby what the hypotenuse of that right triangle is. 67 3/16 is my answer. And then I need to know what the angle is there. So this will allow me to make those braces and have them come together. And I wanted to just pop down to the CAD lab and do this at the school, but I didn't have a login. So it's 61 degrees. I believe it's actually closer to 60.5. But this dimension style is rounding. So 61 degrees will put my vertical right snug to the back of this plane right there. And it'll butt up here with the one that goes left, where this is going to go right. And I basically just didn't continue to model it. I just have some sketch lines in here, triangle shape showing in the model, or in the drawing view. So I know that I need to find 67 3/16 of an inch from long to short on a rhombus shape on a 2x6, and I can make 4 of them, and they ought to slap in here on either pendulum. And I can tell you that the ship's wheel size, its overall height, the amount that we can see of a 6-foot person's face, all the way down to this surface here, is going to work, real well for us. We've got plenty of 6x6 to make this happen in either one of those pieces, and then just, continue to flesh this thing out. Okay, so we put a nominal 5/8 sheet on there. So we're at 65 15/16. (65 15/16) Close enough. That's the most sort of unprofessional way of checking that this is at 90 to this. You could throw a level on that, but you're going to have the same problem. What's the floor? Is the floor level? So I actually almost just measured the floor, which is what we did. Anyway, that right there is ostensibly perfectly 90 degrees. The reveal on these components, let me see if I can turn on my headlamp. It's just a matter of where to pin this thing. So that looks like 2 3/4, 2 1/2, well, 2 9/16. But notice how this second slab sticks out, and over here we got 2 so that could be tapped a little bit that way. So all things considered, get to a certain point, and then I'm going to bite it with a clamp, and I'm going to drill through everything, probably from the outside to the in, and so that it looks halfway decent. Since you're walking by, it looks like a blown out load of BS. I had to get a monstrous 1-inch draw pin just to get something long enough, and then I had to get a 1-inch auger bit as well, just to get something long enough that'll go through everything just barely and be able to be pinned. But I didn't realize we got this gappage. We're held open by that gappage, and it's a matter of where we're screwed into those 2x10, that second one in. But I think it's just right there. I didn't go down the length of the rest of them at all, so I could let go of 1, 2, and then pull him over with a clamp to close that gap. And because the other side isn't gapped like that. See? We're smooth, which is fine. So if I get rid of that gap, can I pin through all of this to the cotter pin? Not really. Damn. So I may have to make a little bit of a counter bore. I don't like to do that because it's supposed to keep your fingers from getting smashed, but I'll probably counterbore the inside so that it can have a pin and have a cotter pin in it. And it'll work as a lead to help you get the pin zooped into the hole. And I don't think I want the handle facing out, but you never know. Because in that case, I'd want a counterbore. You know what? Just barely getting through everything and having this cotter pin flush to the face is also going to be a problem. So you may want to counterbore both ends just so you have some negativity to get around, get your finger in it and pull the pin out of it. Once you remove material, you can't put it back. So this is an off-the-shelf. This is the second time I bought a pin for this, actually. First time I forgot that we had 2 layers here, so I got something that would go through all of that. So we'll do something with this and get it drilled anyway, so it can be pinned today. I'd like for them to try and put the number of kids up onto it today that we're talking about and get a sense of how they feel up there and how it looks overall without probably moving it. But so far I got to get it pinned together. right, it's time to put in the vertical stops out here that will create a far better way than this weight pack crashing into that cross piece. I think I don't mind the extent to which it tips down when it goes all the way to the cross piece, but I don't think we need it to clank when it hits that. So stopping a bit short, and also a finger pinch situation, I think that stopping a bit short of that. But I'm also fairly sure that I'm going to install a much lighter component at this same angle in the same place between there and there on the other side. And then because the weight breaks that plane a little bit, you know, I wonder if, looking through the camera, if I were to just back it down to where it doesn't, I could slap plywood across from here to here, and it would essentially relieve any kind of pinch situation, especially if I stop short here, then in there it could never get your finger there. It's probably ideal to cover that with a simple rectangle. So if I'm trying to keep these below this plane, like comfortably to where they're not going to bump into it, that's pretty close there. And it means if I was able to get to 48 inches out here, which is what I just checked my theoretical, like a nice round, so a difference of 66 to 48. So I'm still at, well, it did come up quite a bit there, so 2.5 inches higher. And so when the ship wrecks, they're taking Prince Eric off of this and up toward the basking rock. So, you know, it would be relatively simple to add a thickness and move that cover out more for the sake of taking more of this and still not creating an issue. So anyway, figure out that, and then I know that this and this are coplanar at 10-foot widths, equal from the center, when this is normal. The problem is when it tips down, the angle is actually missing this block. So we need to move out a bit to hit it. And so I think I'll just add another layer before that stop and just run everything together right here. It won't hurt for that to be 3 layers thick. It's the quickest and easiest way to do this. But the end, I would like it to engage this surface flat. And if I just put a plumb cut on that stick, then the inner edge will be engaged, but not the full end of the stick. And then it couldn't deflect or whatever. So just as a best practice, how to get the angle that I need to put on that end and the overall length. Well, the length will be to the long, from up in there to here, and then the angle will be undercut to intercept this. The angle will be the same as the angle between this horizontal base and going up that pendulum arm. So if I take that angle off of there and I take it over and I put it on this block, you can see they're even in alignment here, which isn't often the case. You can see that that'll be the same angle that I need on that stick. So I'm going to pull it from there and put it on these old 2x12s that were left over from one set, I think from Mamma Mia. I think they're stairs. No, they're going to be from last year. They're newer than I thought. But there's almost everything that I need, and keeping them at 2x12. I had been looking for 2x8. So it won't hurt to get rid of most of that notch. They'll work in this application. We don't have to buy anything new at all. These, don't worry too much about these. I got all the way here with them before I realized my idea wasn't going to work. So back to work. So I'm taking one more look at this, and I think that I could further refine this in a kind of a big way. Essentially, right now, the first and second tier, like bean shape, is from a full scale 4x8 sheet of plywood. So you should be able to get this and this out of a full 4x8. So I started thinking, this profile does nothing but control these arches to this point on both sides, and after that it's unnecessary. These arches start jumping between the bottom plates, so like the whole back half of that's unnecessary. So, and also if I were to cut through that area, I've also practically got exactly what it would take to make this component and this component right there in the rest of this sheet. And so I think that's exactly what I'm going to try and do. It makes this a simple, like practically a half circle, but I think that it can just notch. It'll just notch into the bulkhead that runs in the middle of this thing. So the bulkhead for this model was made in two pieces, but it would be made in just one piece for the full size, and it would just have some kind of interlocking notch on the center, or at this location, and on the center line of this, as per it being folded off of the upper part. But I think making the bulkhead would have to come out of another sheet of plywood. So all three layers to this construction, plus this tab, and if not the tab, then it could be made from the other sheet, would come out of the first sheet, and then we'd have to have that second sheet. And I think then that I could even, you could make some other rocky outcroppings in these areas with what you've got left for plywood, or use it for the rest of your project. So it's unfortunate that it isn't either a clean one or a full 2 sheets. It's like a sheet and a half of 3/4 inch plywood, and hopefully just some corrugated cardboard, a couple of casters. We will need some dimensional lumber to make some supporting blocks, I think, so a 2x4 or something. But I think it'll be a pretty effective set piece from a aesthetic and a technical standpoint, logistical standpoint, if I can get this right. And I think that the big step in that direction is to not need these two pieces from a full sheet, and then to try to get this component that exists on like a third of a sheet of plywood off of the long aspect. And then you need this long thing, this long bulkhead out of what's left of it. There really isn't a place to get a long, that's probably, I think it came out to like 6 feet almost, 5.5, 6 feet long. There won't be anywhere left on the sheet after you make this out of another sheet. So it would have been a difficult 2 sheets to make this way. And so we'll just be more efficient, I guess. And anyway, it's time to try and get it out. I think I'm going to have the fog machine in an opening here, and then covered with some kind of mesh that, when painted in with the rest of the finish of the stone and viewed from this angle, you don't realize that there's a big opening. So that might take a little doing. It very well may just come down to painting some heavy fly screen, the same colors, and speckling through it, and just choosing to fade this to a darker tone in here just to accommodate some of the black tone that would be seen through it. And so we can have fog here, and I believe that'll be how we kill Ursula. And it will also, when viewed this way, in front of Ursula, and I think we'll also be able to come up behind Ariel singing on the stone, which, like the Disney film, there's a big wave that splashes behind her. It's like the quintessential Little Mermaid kind of snapshot. So maybe we could get blue underlit fog to come up behind her when she's singing, and obviously whatever purple green when we kill Ursula. So time to probably try and build it for real. Okay, the real life model worked out a lot of the mechanical aspects and wrapped my head around the idea, but I probably should have moved into a CAD model so that things like the material thickness and the fact that I wanted, like I did here, the miters to like laminate together and play out toward a knife edge just to maximize engagement. I'm gonna end up gluing and screwing this and probably building blocks to support some of the elements. But what I'm getting at is I forgot to cut an angle on this piece to intersect the piece that's at an angle that the casters mount to, and because this slid back to get the angled edge planar with this, I'm missing that amount right there. And, you know, again, dealing with all of your shapes as though they exist on a paper thin or non-existent thickness will get you into this kind of trouble. And it only gets worse the thicker the material. So, in every other case, I would have absolutely built a CAD model. I would have likely printed the stuff full scale, put it on the sheets, cut it out exactly, and put together a little kit of parts. However, this is a fast-paced project, and I'll be able to doctor this and make it work. So, some things that we're learning, I think we want to try and get the fog. I thought the fog would do a wave splash in front of Ariel as she's singing. However, the wave actually splashes behind her, and so if we were to shove the geyser all the way to the back, it still doesn't come out as far back as theoretically possible. It comes out logistically here-ish. So she's going to have to be quite a ways out, and she's got a long dress to be a mermaid at that time, so it won't be a case of just being able to move her legs out to either side and let the fog come up between her, like forelegs basically, behind her. So we've got some things to work out there. However, we also want to try to kill Ursula this way, which would have her scrambling up the rock with the house, the audience in this direction, scrambling up this as it's finished to go in her lair, where this side is finished as that protruding rock. This has more of whatever's going on in her lair. But if she backs up to the top, and then the fog comes through the base of this thing in front of, between her and the house, the audience, then she could move up and over this and down onto the floor and stay sort of out of sight there. So the loops of cardboard are going to actually take the shape well beyond, in this scale, 8 or 10 inches left and 8 or 10 inches right. So we're going to be significantly wider. And the only problem that I've got is the way that this thing is designed to move is to tip down and wheel away. So to be out here, both of the different performers, to basically be able to go up and over the edge of this and down the other side, their entire body weight plus costume and everything, microphone, everything, shouldn't be tipping this forward. So that's the type of thing where if I could do FEA and I could load this with, you know, 200 pounds or at least 150 pounds to be completely safe, because as soon as you start adding inertia, you can load this with more than the essence of the weight of the item itself. So we want to be over. However, I didn't do any of that either. So I'm loath to make the footprint even that little bit smaller because it makes it a longer lever arm, makes it easier to tip this down. So I'm going to just sleep on this and come back with a solution to what I want to do. I don't want to buy any more material. Happily, the 2 bulkheads I ended up getting in one of the circular quadrants of the surface for the Shrek Tower a couple years ago. So we didn't have to go out and buy more than 1 sheet of plywood. I want to stretch this and not get another one for any reason. Certainly not because I made a mistake. So we've also got steel bricks that we can put. I can put 1 horizontally in the back, 2 here and 2 there to counterweight. I can build more ways to put weight at the far end, but in the end, we're working against crew being able to come out here and get this thing to tip up to its wheels to move it around. So it's supposed to be something that somebody can deliberately push down onto its wheels and then leave, as well as a performer can go out at the same place, weigh it down, and not get it to try and roll away. So we're going to actually probably have to pick our heaviest and strongest crew person to be responsible for the piece, put as much weight in it as humanly possible, where it can still be moved like that, and then see if the performance ideas that we have will work. And we got to do that as soon as possible. And I've also got to try and send that fog that way, even just a little bit. What I like to do is to sit a sonotube, cardboard tube, around that rectangular outlet. So point to point, it's about 8 inches. So an 8-inch sonotube will go right onto that, and it'll keep everything from going into this cavity. It'll send it right up through this face. So I just need to get what amounts to an 8-inch circular hole straight through here. But it can't be normal to this face as a circle, like a drill op, because as soon as you take that circle and squeeze it like this, it becomes an ellipse. And so I actually have to plot out an ellipse through this surface that will allow the 8-inch tube to go straight through it smoothly. So to do that, I know that I'm at 40 degrees exactly from here. And so I can actually put a hole through in CAD, a plane at 40 degrees, and then I can get the line that it leaves that's an elliptical. I think it'll probably be long this way when you look at it. I can print that out to scale with some major axis marks, tick marks, and put them on this center line and just move it up and down here and basically trace it, and then just cut it with a jigsaw, and it should help a perfectly cylindrical thing go straight through at 90 degrees to the floor, intersect that, and then once it's through there overly long, then I can just cut it, or maybe just trace this line with a pencil and just take it back out and hand cut it. Anyway, it'll connect that thing so that all the fog is coming out. And then you got a big hole in this face of this thing, and then we're gonna need to probably cover it with something, and even a fine mesh, like a more substantial mesh, so you can't put a foot right through it or do anything like that. Hardware cloth maybe, and then a fine mesh like fly screen. And then when this whole thing gets painted a base color, and then whatever we do for Ursula, all of that will get painted together, and it should hopefully kind of disappear to the eye, even though the fog can come out of it, even though somebody could kind of maybe not step their whole body weight on it, but keep their foot from going right in there. So we've got some technical things to figure out for this thing. And so before I get to all of that, I do not want to just put glue on all this joinery and screw it together and to dry until I'm certain that I've got everything kind of sorted out. But I don't want to re-screw through into the edges of this plywood, as I did here, more than one more time with glue in there. So this is a real tricky piece. So that we're in the end, it's all well screwed, it's all well glued, it's all completely dry. There's a place for everything, and it works as intended all the way around. Lots to do on this. And so the bones, the meat and the potatoes here in a couple of hours is just the tip of the iceberg, just the tip of the basking rock. So stay tuned on this one. Time to go sleep and maybe just relax. I made this mistake right here at the end of my workday. Hate when I do that. Don't like to push. It's always so satisfying to get a little bit farther, but if it's risking a mistake, no.